Hello and welcome to National Hog Farmer at the Slat Level. I'm Ann Hess. Today our topic is From Biology to Barn, Translating Science to Practical Pig Management Solutions. And on hand we have Dr. Jay Johnson, University of Missouri. Welcome, Jay, and thank you for joining us today.
Thank you for having me. It's a pleasure to be here.
Before we jump into today's discussion, I'd like to remind the audience you can post any questions you may have in the chat and we'll be sure to get those over to Jay. So, Jay, for those who might not be familiar with your expertise, your role there at the University of Missouri, give us a little background.
Sure. So I'm an associate professor of animal welfare and stress physiology here in the Division of Animal Sciences at Mizzou. Most of my research focuses on applied management solutions, both through nutrition, decision support tools, and genetic selection to help pigs overcome heat stress at multiple life stages, starting at gestation, working all the way through the market phase.
Very good. Well, you recently presented at the American Society of Animal Science and gave a presentation there on how industry advancements have improved productivity, but heat stress is still a limiting factor. How so?
Yeah, that's right. So my talk there was really focused on, how heat stress has impacted our herds, particularly nowadays, relative to even 20, 30 years ago. And so we know that research advancements have led to a lot of industry advancements in our swine production industry. Of course, we've started with basic genetic selection, which has since evolved to genomic selection, and even now we see gene editing with our, PRRS-resistant pigs, for example. We've also improved how we fed our animals through improved nutritional formulations and new engineering strategies. Things like sow cooling pads are helping our lactating sows overcome some of those more hot times of the year. And as a result of this, of course, we've seen improvements in our productivity, particularly in the efficiency of how we produce pork products. We see, based on compared to 1980, we're producing more pork today with even less pigs than we had back then. But as we know, heat stress can be a limiting factor in our production system, right? We see here in the United States a large uptick in sow mortality in our summer months, between about May through August. We observe decreases in reproductive efficiency. Either our sows fail to breed or they don't quite reach all the way till farrowing. They may have a lot of stillborns or even abortions that happen in that later term. And when we think about our grow finished pigs, we see pretty consistently lower feed intake, lower average daily gain associated with that heat stress response in those animals.
You also discussed in utero heat stress during your presentation. Tell us more about that and what caregivers might see in terms of symptoms or challenges in the pen.
Yeah, so this is some work that we've really been focused on for probably the last 13 to 14 years. And so a lot of times when we think about heat stress, we think about that direct effect on that pig. Again, we talked some about growth rates or reproductive efficiency or even mortality. One of the things that we were really interested in is how do those pigs that were exposed to heat stress while their mothers were being exposed during gestation, how do they respond later in life? And we've really done a lot of characterization of the phenotypes of these animals. We see that they have impaired immunity, right? They succumb to disease a little bit more easily than maybe an animal that wasn't exposed to in utero heat stress. They have greater heat stress sensitivity actually later in life. And so, for example, if you have a replacement gilt that may have been exposed to gestational heat stress, by the time she reaches breeding age and maybe gets bred during the summer, it's possible that she's more likely to pass on some of those negative in utero heat stress phenotypes to her offspring. We've also observed things like reductions in both the quality and the quantity of the meat that we're getting from these animals. And even more interestingly, we see that it actually alters how these animals behave. And so when we mix them in different groups, right? So maybe during weaning or during mixing events, thinking about group housed gestation, we see more aggression out of these animals as well, which can have some negative implications towards not only the welfare of these animals, but also how they actually produce for us. And so when we think about some of the industry implications of that in utero heat stress, we don't really know what the economic consequences of this are. We think that they may actually be greater than just heat stress by itself, primarily because you're getting these long-term effects the short-term gestational heat stress event on these animals. And so even if you have an animal that was exposed to, let's say, gestational heat stress for just the first half, you may see some of these negative consequences all the way into November, December, and January, even when these pigs aren't being heat stressed, right? And so, as we think about ways to try to mitigate this in our herd, really prioritizing keeping those gestating sows cool through either increasing our ventilation capacity or cooling strategies within our gestation facilities may help prevent this from becoming a larger issue.
So, how are producers dealing with heat stress at the slat level now? What are they getting right? What could be improved upon?
Great. And so this is a question we wanted to ask. We published a study back in about 2025 where we'd done a survey, got responses for almost 70 sow farm managers throughout the US. And one of the questions we'd asked was, how are you currently dealing with heat stress in your facilities? And what we observed was that the top four strategies that are currently being used are primarily management strategies. So either the use of drip coolers, evaporative coolers, fans, or sprinklers in those barns. And so our follow-up question to that is, when really are these producers using these management tools, right? We have all these tools in our toolbox, but do we really know when the best time to use these strategies are? And so one of the other questions we asked in that survey was, when does heat stress actually occur, right? And so we got a wide variety, a large range of responses in different categories of pigs, ranging from nursery to grow finish, market-sized pigs, mature boars, and even our sows. And what was a little surprising to us was that we got quite a bit of variability in response among the individuals that did respond to our survey, ranging from between about 6 to almost 10 degrees Fahrenheit in variability in response. And when we actually look at some of the current recommendations that we have, that I will mention, those current recommendations are based on pig genetics from almost 30 to 40 years ago. But even so, a lot of our responses were about 4 to 7 degrees Fahrenheit greater than our current recommendations, which was a little bit surprising to us. And so, sort of in response to this, over the last probably 6 to 7 years, we've been working on developing more accurate decision support tools that producers can use to really know when they need to start using some of these mitigation and management tools that we already have at our disposal. And so the way this decision support tool works is it's actually using a combination of temperature and predicted humidity and predicting change in baseline behavioral and physiological responses of those animals. And so instead of a simple arbitrary value that we can tell producers, it's actually predicting what responses their pigs may have to varying temperature and humidity combinations. And so one of the things that we've done to really improve on-farm usability of this tool is we've integrated this tool into a free-to-use smartphone app that you can download from either iOS or Android. And this app will provide real-time information on that thermal stress risk, as well as management recommendations, both at the slat level as well as during transportation. You can use this app to get alerts based on your selected location, production stage, and even the expected temperature level in your barn. And it's available currently in 4 different languages: English, Spanish, Brazilian Portuguese, as well as Chinese. And just to give you a quick demonstration of the app, we'll see this in our home screen where you'll see your current location, and you can select either open, early, or late gestation animals. You can get predicted temperatures by hour of the day. You can also go in and you can enter a specific city that you'd like to get your thermal indices at. In this case, we entered Ames, Iowa. We added that location, and then it comes up on the screen as your new location, and you can see what the index is. The app will also save various locations. So if you have barns in multiple areas of the US, you can get them. There's a tool that shows you what the expected behavior and physiology will be, as well as some management and mitigation recommendations that we've developed in consultation with other pork producers, as well as the National Pork Board. You can go in and build your own index. And so if you're trying to figure out where you want to set your high temperature set points, you can put in a combination of temperature and humidity. And you'll see that depending on the humidity, that temperature may elicit a different outcome. One of the newest features of the app is that we offer alerts, right? And so you can tell the app what time you want to get those alerts, what warning level you want to get that alert at, what specific gestation stage you're more concerned about, and which specific locations that you'd like to have those alerts for.
Well, what a great tool to have right there at your fingertips and just to keep a pulse on where all your pigs are in your system and what they might be looking for as far as symptoms and challenges and when it's time to intervene. That's a great tool. You also discussed genomic selection for heat stress tolerance. Detail for us how that works and how a production system would go about implementing that.
Yeah, so this is a area of research that we've really been focused on over since about 2020. And so usually when we think about genomic selection, for thermotolerance, it's generally associated with negative productivity responses in our animals, right? And a lot of times this is because when we select for thermotolerance, what we're actually selecting against is metabolic heat production, which is selecting against performance in that animal, right? And so we had asked the question, what if we actually selected for animals that are better able to lose body heat as opposed to animals that simply lower their metabolic heat production and lower their productivity? And so the selection trait that we decided to use was actually the rate of that body temperature increase as a function of those environmental conditions. And so what we end up with is an animal that would be more sensitive would have a faster rate of body increase relative to an animal that's more tolerant would have a slower rate of body temperature increase, potentially as the mechanism being that they're able to lose heat better in those environments. And so using this trait, we were able to develop genomic breeding values where we did find that our heat sensitive animals did separate from those heat tolerant animals. And then this was heritable from about 0.24 to 0.29, right? And so relatively moderate to high heritability for this trait. And so using this information, we developed a divergent line of pigs for either heat stress sensitivity or heat stress tolerance. And again, this is really mostly focused on our lactating and our gestating sow population. And so with this base population, we then bred for our F1 generation, we then bred for our F2 generation, and finally our F3 generation in order to do some biological characterization to see how does selecting for this specific trait impact that animal's ability to either thermoregulate while either maintaining or improving performance. So what we identified was that in our founder population, under a heat load, these lactating sows were able to maintain similar body temperatures, whether or not they were either sensitive or tolerant. The main difference was that our sensitive animals actually lowered their metabolic heat production and productivity, whereas our tolerant animals really prioritized some of those heat loss mechanisms. They would increase the respiration rate a little bit faster, and they actually changed some of their behavior. They would interact with their waters a lot more and spray themselves a lot more. And so they were getting to the same point, at least in terms of body temperature. They were just using two different ways to get there. And so when we go back to whether or not that animal is using metabolic heat production loss or increased heat loss, what we've essentially done is characterize our sensitive animals as ones that prioritize dealing with heat stress through lowering productivity and their heat gain, whereas our sensitive animals really prioritize losing heat under those same situations. As we've moved into our F1 generation, we've started to see that increase in heat loss is showing itself as decreased body temperature response. We observed that those tolerant animals under heat stress and even overall do have lower body temperatures. One of the more exciting things about this, though, is that even though these animals seem to be able to deal with heat stress better, they're still outperforming our sensitive animals. We see that those tolerant animals in this particular study generated about 1.74 more piglets per litter under that heat load condition. And when we take their piglets and put them into the nursery, we find that their piglets actually outperform those of the sensitive animals. They would eat more by almost 14%, and they would grow faster by about 6%, relative to those sensitive animals, right? And so we're seeing these downstream positive impacts on their offspring with this selection trait. And so, again, as we start to think about some of the implications of this selection protocol, really, we're seeing that we can improve heat stress resilience in our animals without compromising that productivity. The key is the specific trait that we're using to define thermal tolerance in this instance. In this, we're seeing some enhanced reproductive efficiency under these heat stress conditions. And we're also seeing some benefits to that next generation. I'll note that those animals in that nursery weren't even exposed to heat stress. This was just under normal production conditions. And we're still seeing some positive impacts on their growth performance of those offspring with that selection protocol.
Yeah, those are some significant results that you're seeing there at the slat level from this. Bottom line for pork producers, caretakers, support staff, how do these new applications, new technologies improve productivity, and how can they better adopt these science-based strategies to solve pig management solutions?
Yeah, that's a great question. So I think the bottom line is that we really need to be more proactive versus reactive when it comes to things like heat stress, right? And so understanding when we need to use the technologies that we already have, employing them at the right time, using things like hot hog or your algorithm of choice is really beneficial. I think, as we start to move forward and, we've made genetic progress in our animals, but maybe adding some of these other traits within a larger selection index, especially depending on where you're going to raise those pigs, right? So maybe you want a pig that's a little more thermotolerant if you're raising them in North Carolina versus potentially Minnesota, for example, right? And finally, I think that as we've gotten greater understanding of how that gestational environment can even impact productivity in those offspring, really prioritizing how we're managing those gestating sows, especially during summer months, and potentially putting a little bit more inputs as far as cooling technologies into those gestation facilities to mitigate some of those potential downstream issues.
Dr. Jay Johnson, University of Missouri, thank you so much for taking us in the barn today and sharing your expertise.
Great. Thank you for having me.
For more pork production conversations and demos from the slat level, be sure to check out the At the Slat Level page on National Hog Farmer's website. For National Hog Farmer, I'm Ann Hess.